Hello, learners. Welcome back to our segment, a continuation of what you're doing earlier on. So in this segment, basically, I want us to handle a question. The second question in our binomial probability distribution. Remember, we had introduced this in our last class, and we also had another class for a question. So let's do this second question, which will make sure that our confidence is very high when it comes to matters to do with binomial probability distribution, right? So, on that note, I want us to check out this second question. This second question, illustration question number 2. I want us all to be on that question. See what you asked. That a survey was conducted in Pamoja village to establish the proportion of households that were affected by a certain pandemic. The results indicated that 40% of the households in the village were affected by the pandemic. So the question that you should ask yourself then, what percentage was not affected? A sample of 6 households was randomly selected from the village. Required, we need to determine the probability that only one household was affected by the pandemic. Exactly 2 households were affected by the pandemic. At most, 2 households were affected by the pandemic, and 3 or 4 households were affected by the pandemic. That's a very good question because I know very well this is a binomial distribution, because as at the end of the day, you need to have the whole values, right? So this will not change. You see, the same concept that we did in our previous class where Mwalimu introduced us to this concept, that will not change. So it's the same concept that you're going to use. Only whatever that is going to change are the variables. And that is what I want us to identify in our question. So what I'm going to do, I'm going to erase this bit only up to that point because I've given you all this, right? We had looked at all this earlier on in our class. So long as you know how to determine the binomial coefficient, then you're just good to go. So long as you know how to determine the binomial coefficient, then you're just good to go. You're just good to go. Okay. So on that case, then this is our task. This is our task. Number one, a good examiner wanted us to determine our item that only one household was affected by the pandemic. So here is what you're supposed to do. Only one household was affected. Only one household. This must be COVID period, right? Only one household was affected. Only one household was affected. This must have been during the pandemic, COVID-19, right? So looking at this case, it is important then for us to have this in mind and to understand it very clearly, okay? I'm having our number of items under consideration. We are talking of what? 6 households, because that is the sample that we are having. So I'm having 6 households here. Item of interest, the first case you're looking at, only one household. Probability of this household to be affected, you're told, we had what? The result indicated that 40% of the households in the village were affected. So you're talking about what? 0.4. Excuse. Probability that the household will not be affected by the pandemic, you're talking of 0.6. So our task here is to determine the aspect of course, our combination, or simply binomial coefficient. A binomial coefficient, we have this formula here, which Mwalimu guided us on our other class. So what will we be having? In this case, I'd be having 6 into x, our x is 1, into n, which is 6, minus x, which is 1, excuse, so that as at the end of the day, we should be having what? We should be having, I taught you that in our last class, so I'll just do it quickly now. 6 shift, sign there. We're going to divide into 1 or sign there times 6 minus 1. We close that so that as at the end of the day, this should give us 6. Right? So if at all I was to have our equation here, only one probability that only one household will be affected, probably that only one household will be affected, I'll be having n, that is a binomial coefficient, 1, right, times probability, which in this case I'm having 0.4 of us being affected, raised to power x, which is 1. We multiply by us not being affected, which would be 0.6. We raised power 6 minus 1. See, n minus x, that's what we should be having there. So at that point, we can agree that our values that we should be having, therefore, with a lot of confidence, we can determine that quickly. We can determine that very, very quickly. Just a moment here. We can determine that very, very quickly. We can determine that very, very quickly. So, of course, our calculator here, we should be having the value that we have already determined here, which is 6. So, I'll be having 6 times 0.4 raised power 1 times 0.6 raised power 5. So, we are getting 0.1866, right? Probability that only one household was affected. So that's what you're supposed to do on that. We proceed to the second part. What the second part, the good examiner told us what? The good examiner had asked us here the probability. So you asked exactly 2 households were affected. Exactly 2 households were affected. Exactly 2 households were affected. So in this case, I'm having P2, probability that exactly 2 households were affected, binomial coefficient, which is 2, we multiply by 0.4 raised power 2 times 0.6, 6 minus 2. So what are we going to have here? What are we going to have here? At this point, this will be simple because here I'll be having what? I'll be having 2. And here I'll be having what? I'll be having 2. So therefore, what will be your values? My value there, I should be talking of 6 divided by 2 times, of course, 6 minus 2. In that case, that should give us, of course, 15. So we'd be having 15 here times 0.4 squared times 0.6 raised to power 4. So in that case, I'm getting 0.3110. Kindly you can confirm probability that exactly 2 households would be affected. Exactly 2 households would be affected. So as simple as that. We proceed to the next bit. You see how easy that is, right? So the next part here, the next part here, a good examiner had asked us to, at most, two households were affected by the pandemic. At most, two households were affected by the pandemic. If at all you're talking of at most two households, right, were affected by the pandemic, how will you go about it? That is to say, not this is that is to say, talk about a maximum, not per se at least that is a maximum, right, of two households. That is because you asked at most two households were affected by the pandemic. At most two households were affected by the pandemic. So that will be quite easy because all we need to do is simply just to get the combination of 3 and the next item. So long as it is above the value that you're looking at, most 3, at most two households. So in this case, allow me to erase this point. At most two houses, that is like or, right? So at most two houses, at most two houses were affected by the pandemic. At most two houses were affected by the pandemic. So in this case, this will be easy. We can decide to, of course, determine, of course, probability of 3 and 4, right? We can determine the aspect of probability of 3 and 4. Then we get, of course, what? We get the difference on the same, which in this case, I want us to work it out very quickly here. I want you to give me this, just using the simple way that Mwalimu has shared with us, right? Probability of now 3, where you'd be having 6 C3 times 0.4 raised to power 3 times 0.6, 6 minus 3, and we determine for 4, 6 C4 times 0.4, at least so that you can be able to see if at all you've mastered 0.6, 6 minus 4. See, as easy as that. Kindly try to work it out very quickly. We see if at all you've mastered that. See if at all you've mastered that. So that will be easy. Believe that at least you've scratched your heads that much, right? So I can basically just remove that bit. So, of course, the same case will apply. This is the only bit that you need to understand, right? So, like for the first bit, what I'm supposed to do here will just be having, of course, that should give us, of course, 6, okay, divide by 3, into 6 minus 3. So the first case will give us 20. Six, of course, we'll be having divide by 4. 6 minus 4. This will give us 15. So that if we have that, then what will we be having here? What will we be having here? What will we be having? So at this point, I should be talking, of course, of 20 by 0.4 raised to power 3 times 0.6 raised to power 3. So I should be talking of 0.27. 0.2765 15 by 0.4 raised to power 4 times 0.6 squared. That should give me 0.1382. Kindly confirm if at all we are getting the same values, my good students. Kindly confirm if at all you are getting the same values, just whatever that Mwalimu had guided us, just the same as what Mwalimu had guided us. So that once we have that, of course, we take 0.2765 we less 0.1382, right? So that as at the end of the day, we're having, as at the end of the day, the combination is giving us 0.1383, 0.1383, 0.1383. So having that, I want you guys to complete the other one. I know now it will be simple. I want you guys to complete the other one. I know now it will be simple. So that in our next class, let us introduce Poisson. That is, of course, you normally call it as a Poisson, right? But you normally just term it as what? Poisson distribution. So let us introduce that in our next class. To that point, guys, thank you so much. See you in our next class. Bye-bye.